So in this video, we are continuing on in this Taylor Power Series problem set from a professor at Princeton University, and we're on number 11. We're finding another Taylor series or Maclaurin series for this function f of x equals 1 minus cosine of 2x squared over x, and we're going to find seventh derivative at 0 and the eighth derivative at 0. So if you watched problem number 10, hopefully this is another good practice problem if you needed another one. This is honestly pretty typical one in my opinion. So let's go through it. Okay, so you should start with a known Taylor series, Maclaurin series. We know the Maclaurin series, hopefully, of cosine x. I would recommend you memorize it if you haven't at this point. I'm assuming you're studying for an exam at this point or something like that. So I would recommend you memorize sine x, cosine x, and e to the x. Depending on the school, you might need to know the binomial one as well, which I'll cover in probably some future video. Okay, so we start with cosine x. So if you remember the expanded form, it's just the even powers. And you alternate signs, something like that. That's how I remember it, honestly. It's 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial minus x to the 6 over 6 factorial, so on and so forth. Or you can remember it in the summation notation as well. I would recommend both technically. Sometimes the expanded form is more helpful. Sometimes the summation notation is more helpful. You'll see exactly in this problem what I mean. Okay. So I can have cosine of 2x squared. So basically, we're trying to start from cosine x, something we know. The Taylor series at 0, by the way. I'm just gonna say Taylor series. That's what most people say, honestly. Okay, so what was I saying? So we start from cosine x, and we're gonna try to match the function we want up here. So we want cosine of 2x squared. So wherever there's x, replace it with 2x squared. Okay. Properties of exponents, you can rewrite it like this over here. Or let me go from here first. Okay, but this is properties of exponents. Now, the reason I wrote it like this over here is, well, we know the first term is 1. So even if we plugged in 2x squared as x in the expanded form, this 1 doesn't make a difference, right? So I can just move that outside and then start the n from 1. So basically, instead of starting from 0, which includes the 1, I take it out and then start it from 1. Okay? Hopefully that makes sense. Why do I want to do that? Well, because the next step is I want 1 minus cosine of 2x squared. So when I write it like this, it makes it really nice because I have 1 minus cosine 2x, which is right here. Okay, so I put it in parentheses right here. So 1 minus 1 is 0. So we have a negative sign out in front. The summation as it goes from 1 to infinity of whatever is left. Or whatever that was there, okay? So it makes it a little nicer in my opinion, okay? And this minus sign I can move inside as well. So it's just minus 1 times this, right? So I can increment this power inside the series by 1, okay? Now I just divide by x to get it to match the function, okay? So when we divide by x, you just remove 1 power of x over here, right? So that's what I did right here. Okay? So if you had done term by term, it should be something like this. 4x cubed over 2 factorial minus 16x to the 7th over 4 factorial plus 64x to the 11th over 6 factorial, so on and so forth. And then if you simplify it a little bit, it'll look more like this, okay? The reason why I want it now in expanded form is to answer these two questions over here. Find the 7th derivative at 0 and the 8th derivative at 0. Okay, so let me explain this one more time slowly, or kind of slowly, to how to evaluate these. Okay, so imagine we do the power rule 7 times to get the 7th derivative, okay? If you do the power rule 7 times on 4x cubed over 2 factorial, it would have gone to 0 already. You differentiate it 4 times, it already go to 0. Okay? Now, if we differentiate this 7 times, what would we get? So we ignore the constant of minus 16 over 4 factorial first, okay? We would get 7x to the 6th, and then 7 times 6 times x to the 5th, and then 7 times 6 times 5 times x to the 4th. Hopefully you see the pattern. So when you take the 7th derivative, you do the power rule 7 times, so this power would be 0, but you have a 7 factorial out in front. Okay? That's number 1. And then number 2, all the subsequent terms, you'll still have some power of x remaining. So when you plug in x as 0, they would all go away. Okay? Hopefully that made sense. So then that's how you evaluate these quickly. So as I said, we'll have a 7 factorial from doing the power of 7 times on this x to the 7th term, right? Okay? And then we still have the minus 16 over 4 factorial out in front. Or I guess we can look here, minus 2/3. Okay, so that's why in the previous video, if you watched that one, I said we take the coefficient that's already out in front of the 7th degree term and we multiply it with 7 factorial, and that's our answer. So honestly, I would just leave my answer like this over here. 7 factorial times minus 2/3. I would not bother simplifying this, but since I had a calculator, I just plugged it in as it was. It should be a minus, first of all. I don't know why I put positive here, so apologize for that, but let me just quickly check that this is correct. Give me a few seconds to pull up my calculator on my phone. The calculator, I need 7 factorial, and then times 2 divided by 3. Yeah, that's right. So it should just be a minus sign there, my bad. Okay. Now, to answer the 8th derivative at 0, we use the same logic. What's the constant out in front of the 8th derivative term? It's 0. So 0 times 8 factorial is 0. So it's 0. Notice there's no extra 8th term, right? So imagine doing the power rule 8 times. You want to have anything there. Well, you have nothing there in the first place, right? So then doing the power rule 8 times, these first two terms would go away. But this will still have some power of x. So when plugging x in 0, it'll go away. That's why, and similar for all higher powers of x. So that's why it's 0. Okay, so hopefully in this example, if it wasn't clear in problem number 10, hopefully I cleared it up with my explanation for 7th and 8th derivative here. Okay, all right. Again, this is, in my opinion, a pretty typical problem. The more it's not really intermediate, but on the easier intermediate side, I'll say. I've seen many of these before, so that's why I say typical, but you got to be able to think through it, basically. So that's why it's not just a blind mimic what your teacher did, per se. You got to think through it. And once you think through it, it's pretty simple, actually. Hopefully you see. All right. As usual, if this has helped you with your studies, please give this video a like, and it'll be even better if you subscribe to the channel. And hopefully see you in the next video. Bye.